Hey everyone. I guess good morning because it's like 3:09 in the morning. We're gonna go ahead and I'm gonna go ahead and show you a I'm gonna show you both methods for balancing a chemical reaction. So there's my method, the guess and check method. It's tedious, but after you get a lot of practice, it works. That's the way I learned it in chemistry class. In my intro to chem class, that's how I learned it. I learned it that way in high school. I learned it that way in junior high. It's just the way I've learned it, so it's the way I do it. I will also teach you the Dr. Van Doren method, the algebra method. I'll use the same chemical reaction just to prove that it does work either way. So this video is a long one. Be prepared for it to be long. So the first half of it's going to be my method, the normal guess and check method. Not normal, just I guess my method, the guess and check method, and then the second half of the video will be Dr. Van Doren's method, the algebra method. So, okay, the reaction we're going to go with is this, FeCl2 plus Na3PO4 yields Fe3PO42 plus NaCl. So that should be what's on your screen. Let's go and get started. So the first thing I do is I actually list out every single thing I have. So the first thing that I look at before I even list it out is actually notice how PO4 and PO4 are the same. That means I don't have to split up phosphorus and oxygen. I don't have to do any of that garbage because it stays the same, right? PO4, basically this is one PO4 and this is two PO4s. So just realize that if you see something like that, don't be afraid and don't like freak out that you have to make this phosphorus and make this just oxygen. You can actually keep it together as PO4 and this one as PO4 because there's a 2 right there. So basically know those kind of hints. We don't want to make this as difficult as possible for you. These problems should be doable. So if you want, go ahead and pause the video now. Try to do it however you know how to do it, and then just to see if you can do it. And then if you can't, we'll go ahead and do it together. So pause the video now if you want to do it. If not, then let's continue. So the first thing I do is list out everything. So I'm just going to list out what I have. So I have Fe, I have Cl, I have Na, and I have PO4. And I have that for the reactants. I also have that here for my products, right? I have Fe, Cl, not in that order, but still, Na, and PO4. Okay, great. So that's a little weird. Let's fix that. Na and PO4. That's a strange P. PO4. Okay, great. So at this point, just go and count everything. Nothing else to it. Just go ahead and count. So right now I have one iron, two Cls. Oops, two Cls. I have three Nas, and I have one PO4. Right. So 1, 2, 3, 1. Got it. Great. So on the other side, right? Is that correct? That is correct. Good. On the other side, I have three irons. I have three Fes. I have one Cl. I have one Na, and I have two PO4s. Right? I have two PO4s, but there's PO4, and there's two of them. So great. Okay, I've listed out what I have. Basically, at this point, start balancing. So I'm just going to start with the first element or first item. I know that PO4 is not an element, but it is a grouped item. So just keep it grouped because it's staying grouped on both sides. So actually, real quick before you even start, just to clarify that, if you had PO4 here, but then had like P here and like O here, you cannot keep it together. You have to split it up as phosphorus and oxygen, not the PO4. Because it is PO4 and then PO4 on the product and reactant sides, you can actually keep it together because you know that as a whole does not react. It does not break up, basically. So you can keep it together. Anyway, moving on. So, great. I'm going to start with iron just because it's the first one. I normally always start with the first one, like this one or this one. Doesn't matter which one you start with. Just do whatever. So, okay, the first one, iron, I have one. On the other side, I have three iron, right? I have three iron here. So, okay, easy. Let's just put a 3 here. Oops. I did not want that to happen. Okay, whew, that scared me. Okay, so there's a 3 on this side, again. So there's 3 ions on the product side. Let's go just put 3 in front of FeCl2. Great. So now I have, instead of, actually, we'll just cross it out. So instead of 1, now I have 3 iron. And now instead of 2 CLs, notice how that 3 affects both iron and Cl. So at this point I have 3 Fe's and I have 6 CLs, right? I have 3 Cl2s, but 6 chlorine by themselves, right? This 3 is times 2. Okay, good. Okay, hopefully you guys can figure that out. So I have 6 chlorine. Okay, well, I just massively changed chlorine. I went from 2 to 6. So let's go ahead and just balance that out on the other side. Well, I have 6 chlorine here, and I have chlorine right here, and notice how I don't have chlorine anywhere else. So I know that I'm going to be messing with this compound. I know I'm messing with this compound. So I have 1 here, and I have 6 on this side, right? So let's go ahead and just add a 6. Why not, right? It sounds crazy, like, oh, oops, sorry, trying to zoom in on my iPad. Like, oh, crazy, adding a 6, maybe that's wrong. It feels wrong, right? You're adding a giant number, so it feels kind of incorrect. Humor me, try it. Put the 6 up there, great. So now you have, you altered not only chlorine, but you also altered the sodium as well. So the sodium is no longer 1, it's 6, but the chlorine is also no longer 1, it's also 6. So now I've massively screwed up sodium. Let's go back to the other side and just correct it real quick. So I have 3 sodium here, right? It's Na3. Well, what can and I want to make it a 6, basically. I want to make it balanced. So how do I make 3 turn into 6? Well, 3 times 2 equals 6. So I can put a 2 right here. 2 times 3 equals 6, so this would become 6, right? Sodium would become 6 sodiums. And the PO4, well, now I have 2 of these PO4s, right? They're not bonded together, but there's still 2 of them there. So great, now this will turn into 2 PO4. Wait, would you look at that? Notice how on both sides, iron is now the same, chlorine is now the same, sodium is now the same, and now PO4 is also the same. Everything is same, meaning everything is balanced, you're done. Basically right here, it's just a 1, that's it. Good to go. 3, 2, 1, 6. That's it. That's basically how I do chemical reactions. For me, it's really quick, and I know I did pretty much speed through this, but basically all you're doing is you're adjusting one item, you're adjusting one thing, and then going to the other side, and then you're actually, hold on, let me change a different color so you guys can see. You're adjusting a compound here, and you're basically just going from here to the other side to check, okay, well, what can I fix here? Because I messed up here, what can I work with here to, basically course correct everything? That's basically all you're doing. So that's really it. That's my guess and check method. In case the algebra doesn't work for you, if you do still wish to learn the algebra, or do balancing however you want to do it. You're not going to hurt my feelings if you don't like my method. My method works for me, so I'm happy with it. If you're not happy with it, sorry. I can't, please everyone. But if you want to know another method, that is the other method of doing balancing. Now I'll do the Dr. Van Dort method. I'll do the algebra method with the exact same chemical reaction, just to prove to you that it is correct. That either way works. So I'm actually going to go ahead and there we go. I'm going to go ahead and erase everything here and just reuse the same chemical equation. Cool. Okay, back to the chemical equation here. Now, instead of listing things out that I know, I'm actually just going to list them out once. I know I did them like here and here. I'm only going to do it once. So let's just list them out. I have Fe, I have Cl, I have Na, and I have PO4. Again, you can still keep using PO4 as a grouped entity because it's grouped here and it's grouped here. If it broke up here into P over here and O over here, then you would have to break it up and have P and O. But in this case, you don't have to because they are grouped. So hopefully my repetitiveness is making sense. And then great. At this point, also remember that this arrow is now considered an equal sign for mathematics purposes. So hooray. For chemistry purposes, it's not an equal sign, so don't ever think of this as equals. This arrow means yields. So these two reactants yield these two products. But in this case, for the math purposes of algebra, that arrow is aka an equal sign. So okay, great. Now at this point, what I'm going to do is I'm going to skip this one. I'm going to forget all about the first compound, and then these three compounds, I'm going to put variables in front of them, just so that we can play with them a little bit. So you can use A, B, C, whatever you want. I'm going to use X, Y, and Z, or Z, whatever. In the UK, we call that letter Z, but whatever. Okay, so great. At this point, let's go ahead and make our chemical equations. So how do you do that? Well, let's look at the first one, iron. So we have iron. There is one iron right here, right? There's one. That's all we have. So you're going to say 1 equals, well, there's no iron here. There is an iron here, right? There's 3 irons here, actually. There's 3 irons, and it's with the Y. So it's going to equal, so 1 on this side is, so 1 equals 3y. That makes sense? So 1 equals 3y. Moving on to Cl, so I'll do it slowly so you guys can figure it out. So now we have Cl here. There are 2 Cl's here. There's no variable here, so I don't have to worry about putting a variable here. There's a reason why there's no variable right there. It's only 1, because in this case it's 2 Cl. If there was a variable here, like, say, I don't know, L, then you'd have to put 2L. But in this case, there isn't, right? We don't put a variable on the first compound. So therefore, it's just 2. So 2 equals 1Z, or 1Z. That makes sense? So 2 equals, on this side, I have only 1 chlorine. There's no chlorines here. So it's 1 chlorine here, and it's with a Z, or a Z, whatever floats your boat. So it's going to be 2 equals Z. And you can also do 2 equals 1Z, or 1Z. Doesn't matter. In this case, I don't like the 1 there, so I'm just going to go ahead and fix it and put it as 2 equals Z. So we actually know the value of this one, it's 2. But don't get your hopes up yet. So if this were a multiple choice problem and you saw 2 for this, don't answer it just yet, because this is a tricky problem. I picked it for a reason. So, okay, moving on to the next. It says to sodium. Well, sodium has 3 sodiums, and it has an X value right there. Therefore, you're going to do 3X. So 3X equals, where's sodium? There's 1 sodium, and it's with a Z. So one more time. 3X equals 1Z. Hopefully that made more sense. 3x equals z. So, but wait, we already know that z equals 2. That's right, we do know that z equals 2. So we can actually plug this 2 in right here to solve for that guy, to solve for x. So we'll do that in a minute, but let's go and continue and figure out PO4 as well. So PO4, there's only one PO4 value, and it's with an x. So, and there's 2 PO4 values. There's 2 PO4s here with a variable of y. So to do what I normally do, 1x equals 2y. So 1x, or just x in this case, x equals 2y. Simple as that. So at this point, we're going to go ahead and just do some algebra to kind of figure out, let me get rid of that, x equals 2y. We're going to go ahead and use some algebra to figure out what x, y, and z are. Now we already know that z is 2, so let's go ahead and use that value to plug stuff in to figure out what x and y are. So what else has z? This is just simple algebra at this point. So I'm going to change colors actually to yellow. So what else has z? Well, that guy has z, right? Sodium. So we can actually just put 3x, plug this 2 in right here. So 3x equals 2. So if you solve for x, divide by 3, x equals 2/3, right? So keep that in mind, x equals 2/3. We have figured that out. We know that z equals 2, so don't panic that you have fractions. Don't panic yet. Z equals 2. And okay, so now we have x. Well, we can actually figure out our y now, right? Because we have x and y here. You can plug this x value in right here and solve for y. So let's go ahead and do that. I'm going to work over here for this one. So we know that x, which is 2/3, equals 2y. That's a dumb equal sign. I'm going to fix that. Equals 2y. Okay, we have to solve for y, so let's go ahead and divide by 2. Fractional division still trips up people. Don't be ashamed if it does. I'm going to write at the bottom here just so that it makes more sense. Just going to look over here. So y equals 2/3 divided by 2/1. Now we know fraction to fractional division, we multiply and flip, reciprocal. So great. Now we're going to do 2/3 times 1/2. The 2's cancel, so y equals 1/3. That makes sense? Hopefully that made sense. If it didn't make sense, go back through the video and slow it down and pause and try rationing out what is what. So great, x equals 2/3, y equals 1/3, and z equals 2. Z equals 2. So at this point, let's go ahead and just plug them in and see what happens. So I'm actually going to go ahead and erase these x, y's, and oops. I'm going to go ahead and, if I can adjust my eraser, I'm going to go ahead and erase this x, kind of, erase the y, and erase the z. I know where they were, so I'm just going to replace x, y, and z with actual values now. So, whoops, didn't mean to do all that. Okay, so we know that our x, come on, iPad, x equaled what, 2/3? Okay, great, so we'll put 2/3 right here. 2/3. For this one, it's just 1, right? And then, so x, now y equaled 1/3. And now z, or z, equals 2. So great. Now, we're not done yet because we have fractions. Fractions are bad. When you do molar ratios, you need actual whole numbers. You can't have 1/3 of an iron or 1/3 of PO4. It just doesn't work. So what are we going to do? Well, conveniently, these two fractions have a denominator of 3. We can just multiply everything by 3 and get rid of everything. So, okay, let's do that. So if we multiply everything by 3, I'm going to use green. You guys can see green, right? No, let's use a different color. I'm going to use black, just because apparently it works with the gray on gray. So, okay, 2 times 3 is no longer 2, it's 6. Okay? 1/3 times 3 equals, well, 1. Lovely. 2/3 times 3 equals 2. 2. And 1 times 3 equals 3. Would you look at that? 3216. That is exactly what I had last time. If you want to verify this is correct, just go ahead and count everything. 3 iron on this side, 3 iron on this side. Okay. 2 CLs on this side. Actually, not 2 CLs. See, I just made that common mistake. So it's 3 times 2, so it's 6 Cl on this side, 6 Cl on this side. I have 6 sodium on this side, 6 sodium on this side, and I have 2 times 1, 2 PO4s on this side, and 2 PO4s on this side. This is perfectly balanced. So I basically just showed you that you could do either way. You could do the algebra way, or you could do the guess and check way. You got the exact same answer. Now know that the fraction thing, this basically right here, I'm not going to lie, I like this. Also, the reason why that, I made a little bit of a statement in saying that I don't like this way is because I wasn't taught this. So obviously when you know how to do it one way, it's like basically when you're walking, if someone tells you you're walking wrong, you're not going to relearn walking. You already know how to walk. It's hard to relearn everything, especially when you know it for multiple years. So we all have our own ways of balancing. Now, because we are preceptors and you have a professor and SI leaders, you have multiple ways of doing various chemistry concepts, various chemistry problems. You have multiple approaches. We all learn everything differently. We're all unique. So basically, I would say whatever method you like, use it. I would say use one method and go with one method. If you, for some reason, are stuck, if you want to learn both methods, fine. I would advise you learn one method and continue with it because you don't want to get confused on the test. I guarantee you it'll happen. So focus on one method. Um, you can do it the guess and check way. You can do it the algebra way. The algebra way is considered foolproof, so if you do it this way, you're guaranteed the answer every time. Algebra way, it might take you some time, especially because you have to do a lot of practice. For the algebra way, it's basically just knowing the steps and being able to do simple algebra. And you guys are all expected to know algebra coming into 101A, so there should be no issues there. That's basically it. I hope this was helpful. Go ahead and like the video. Don't like the like the videos and put a thumbs up on it. Put a thumbs down on it if you didn't like it. Comment. Tell me how I can improve on other videos. If you have a special request, put it in the comments section. Email me. Put it on Facebook. Do anything you want to. Let me know that you want a video, and I'll make it for you. I'm very happy to make you videos. Obviously, I'm up at 3:30 in the morning making a video. I don't mind doing that. I just like to know that you guys want a video and I can make one. So hopefully this was helpful to you guys. This is again balancing chemical reactions using the guess and check method for the first half of the video, and the algebra method for the second half of the video. Same exact reaction, same exact result, two different ways. Hopefully that helped you. Have a good night. I'm gonna go ahead and go to sleep.